Welcome to my YouTube channel. In this video, we will be talking about the put function block. Put function block can be used for writing data into a remote PLC. If we have a number of PLCs, for example, 2 PLCs in a network, then the put function can be used for writing the data from one PLC to another PLC. Here are the 2 PLCs connected through an Ethernet cable, PLC 1 and this is the PLC 2. Both the PLCs are connected through an Ethernet cable. Well, the connection between the PLCs can be a wired or a wireless connection. But this is not the subject of this video. In this video, I'm just going to tell you how the put function works, irrespective of the medium of the communication between two PLCs. So the put function simply writes data from one PLC to another PLC. And the PLCs must be connected in a network. For example, we have some data blocks in this PLC 1. For example, DB1 and DB2 are the data blocks that are in PLC 1's memory. And in the PLC 2 memory, there are some data blocks like DB3 and DB4. So if we write a put function in the PLC 1 program, then the PLC 1 can write the data of the DB1, for example, to the DB3 data block of the PLC 2 through this put function. In the diagram that I have attached over here, you can see the inputs and outputs of the put function block. In these parameters of the put function block, the most important parameter is address 1, SD1. So in simple words, this input parameter holds the address of the data block to which we will write the data. And this input parameter of the put function block will hold the address of the data block that from which we will write the data, right? So the data in this data block will be copied to this data block. But remember, this data block is in PLC 2, the remote PLC, while this data block resides in the PLC 1, which in this case is the local PLC, right? And the rest of the blocks you may be familiar with are very simple one. Enable, you can put any condition over here to enable the working of this put function block, and once the enable is high, well, ENO, that will be high too. And this REQ, required input parameter, well, you can use a clock signal, for example, M0.5, that keeps on refreshing the functionality of this put function block. So this might be the input at this specific required function block. If we keep it permanent high or permanent 0, well, this put function block might not work. So we will have some input clock signal over here at this input parameter. Well, this is the ID, and these are the addresses of the data blocks to which we will be copying the data. And remember, this address block or this data block must reside in the remote PLC, while this must reside in the local PLC. These are the addresses of the local PLC. Now let me further explain this data block that is written over here, that how it copies the data from this data block to this data block. Well, over here you can see on the address 1 of the remote PLC, something like this has been written: P hash DB 50313.db x 0.0 integer 1. Well, the content have been copied to this data block in the remote PLC. Remember, this is in the remote PLC. And on the other hand, the contents that has to be copied, well, the address is db50312.dbx 0.0 integer 1. So these are the data blocks. Well, this is the data block in the local PLC. And by put function, we write the content of this data block to this remote PLC data block. Well, let me explain the addresses over here. Well, 50313 is the address of the data block in this remote PLC. Then dbx 0.0 is the first bit address of this specific 50313 data block. So it starts copying the data from the very first bit of the data block 50312. In fact, the contents of this data block has to be copied to this. So I will start from there. So this is the data block address 50312. It's the data block address in this local PLC. Starts from the first bit, that is 0.0, and int 1. So we have to copy the integer. Well, it starts copying from the first bit of the 50312 data block, and it goes up to 16th bit. As you might be familiar with, one integer is equal to 16 bits. So what this put function does, it starts to copy the data from the first bit of this 50312 data block, and it goes up to the 16th bit, and all the contents of the 16 bits of this data block starts from x 0.0 are copied correspondingly to the bits of these 50313 data block, which starts from x 0.0, and this one integer, we can also call it as one integer because in one integer we have 16 bits. So the first 16 bits of this data block are copied to the first 16 bits of this data block. So this is how this works. We can also write over here as something like byte 2, and then we write over here byte 2. So what it does, it copies first 16 bits, first 2 bytes, which is equivalent to 16 bits, to the 16 bits of this specific data block. We can also write, for example, byte 3. If we have written byte 3, so it copies 3 bytes from this data block, starts from x 0.0, and it will be written over here as 50313. x 0.0 starts from x 0.0, and 3 bytes are overwritten in this remote PLC with the content of this data block. So this is how the put function works. It is simply copying the data from the remote. It's simply copying the data from local PLC to the remote PLC, and a connection between these two PLCs must be ensured. It can be a wired connection, it can be a wireless connection, depending on the medium of the connection. So in this video, we explained how a put function works. In the next video, I will explain how a get function works in this scenario. Thank you for watching the video. Subscribe to my channel if you haven't, and see you next time.